All right, my friends, welcome back to the Rheia build. We are making some great progress in the job. Fun to have the irrigation supply drop off. That means Scott and my landscape team are rocking on the house. And do you notice the job site fence being down? There's something about that milestone that's really a big deal. Now in this episode, we're gonna jump into the HVAC and commissioning phase. This is really critical and I think doesn't happen super well on custom homes or production homes in America. So we're gonna show you how our HVAC system and some other critical components, we get them started and make sure everything's working well in the house. That being said, this is the Rheia build series in partnership with our friends at Builders First Source. This episode is specifically sponsored by both LG and Carrier. Let's get going.
A Build Original series in partnership with Builders First Source. The Rheia build.
Man, cleaning all the windows in the house made such a big difference. My Pella front door, now that's all cleaned up, looking fabulous. Now this is not the final walkthrough. We actually have my HVAC guys on site. I've got my Rheia duct guy here, and my LG rep is gonna be on site here in a minute, Voya, who's an old friend. But just for a second, let me show you how good this is looking. Now the hardwoods have been uncovered. I've got my Delta Millwork ceiling. Look how nice this home office space looks. But this is a showstopper. Look at this powder bath. This is actually not a powder bath, full bath, right? So this could be a bedroom. The clay imports tile, oh my gosh, amazing. This looks so good. I've got my lighted niche right here. That's that Schluter niche that we saw earlier. And all of this incredible hardware from Kohler just looking fabulous. Now we still have a shower door coming for this, so we still gotta work on that. And as a side note, everything you see here is actually from Kohler. That's Kohler lighting, Kohler mirror. This vanity and top and sink is all from Kohler. I love these because literally this cabinet just dropped into place, screwed into the wall, and the plumbers hooked it up. It's really nice not having to measure and have the countertop guy come out. Looking so good over here. But we're talking today about HVAC commissioning. I wanted to show you a couple things on HVAC. You know, one of the big things in commissioning is getting all your vents on the outside of the house. And I actually brought a couple sample vents. This is the one we're actually gonna use for the dryer. If you don't know this product, this is by Innovate. This is roughly, 40-ish bucks, maybe $45. But those plastic ones that you see for dryers are garbage. Don't use those. Spend the money and get a decent one. These are 22 gauge steel. They're powder coated. You can get them in whatever, well, not whatever, several flavors. You could paint this as well. But the deal is it's got a magnet on this, and see there's no screen on there. When that dryer kicks on and we get a 200 CFM exhaust out of that dryer, this is gonna pop open and there's nothing to obstruct the lint. They make a different version that's intended to be an exhaust fan. Let's say a bath fan, which is what this one would be, or maybe a kitchen exhaust fan. So a 6-inch wall vent, a 4-inch wall vent. I really like these because they've got a built-in screen. So I think we're just checking which color we're gonna use on the outside of the house. Now the big deal that's happening right now is we're commissioning the HVAC system. In fact, Ron from Rheia Duct is gonna be here any minute to help us commission this first floor unit, which you can't see it here, but if you go up in the attic, you'll see all these Rheia Duct home run tubes that we installed on a previous episode. I gotta tell you, this HVAC closet though looks absolutely fantastic. Full waterproofed floor. I've got an overflow pan in here. The drain's all been hooked up. We had my guys paint the gray on the bottom pass through, and then we painted black a little bit on the other side where you're seeing these grills. So this is an upflow unit. These grills are not in place yet, but we pre-painted that all black. So when that grill goes into place, that'll all look black. Now that unit, if you bend down with me, you can see that unit right there. This unit here, or this side pass-through rather, is just to get enough airflow through into that unit. So this is basically just a closet floor that we elevated. In fact, if we walk over here, you can see it. We've turned it from kind of a mini walk-in closet to actually a reach-in closet now. So that platform under there is just simply an air return. into that closet below. And this is just some shelving for games or storage or whatever. Now, when I was here with Mike, my city inspector though, he made a really good point. If this would have been a walk-in closet, this window would have needed to be tempered. It's not tempered, it's not required for a reach-in closet, but had this been a walk-in closet, this would have needed to be tempered. So that's something to think about in the future. And recently I've been thinking about and learning about wildfire resistance, and it's not that much more money to get tempered glass. So on my next project, I might actually look to see what a whole house full of tempered might end up going for. Another thing that Mike, my inspector, cautioned me about that I'll need to fix before my final is we're here in the master, and from the Pella factory, they installed a sash limiter. See this right here? This is intended to make kids not fall out of a second-story window. It limits the amount of escape or fall potential here, but this wouldn't meet code for egress, especially if this is a kid's bedroom. A kid may not see this push the red button and open it designation here. So I actually need to remove those sash limiters from the bedroom spaces. But man, these Pellas look amazing. These were pre-finished black, if you remember from earlier. And actually these windows are the only windows in the house that are triple glaze. And this push-out casement action on this window fixed here, really good U factor, and these windows look fabulous, don't they? Now outside you can see we've got our two outdoor Carrier units side by side here, ready to go. And a couple things I want to make mention on Carrier. These units are incredibly quiet. I need to double check. I can't remember if these are 2.5 or 3 ton units, but you know, Carrier makes really, really quiet outdoor equipment. And these have compressors that can vary in their output. So these compressors that are running, one's for the first floor, one's for the second floor unit, they can run down to 25% capacity all the way up to 100% capacity. So if we don't have a lot of load, there's not a lot of BTUs of cooling or heating needed, these can run at a lower and more efficient using less electricity speed. It also means that both these units run, I need to double check the specs, but they're in the like 40 to 50 decibel range. So they're very, very quiet on the outside. The other thing I want to mention on these is they're quite efficient even at very cold temperatures. These two units right here that I've got from Carrier, down to 5 degrees Fahrenheit outside, I've got 100% of rated capacity. So if you check the specs and see what the actual heating capacity is, I've got 100% of that heating capacity down to 5 degrees outside. In Texas, for me, that means I don't need heat strips. That saves a lot of money, that saves a lot of electricity. These units, full heating for the house down to 5 degrees, and they can even operate in lower temperatures. They're just not quite as efficient. They're only giving, let's say, 80% of rated capacity as that temperature drops below zero. So excited to see those guys get these fully commissioned. We're running now, and the guys are here working on various equipment. So that's really fun. Now, next thing I wanted to mention is in the garage, we have another Carrier unit. This is a Carrier linear recessed mini split. It's a one-way cassette, so meaning it only blows air this direction. And I really like how that turned out. Instead of the mini split head on the wall, this one basically sinks up in between your joists, or in this case, in between our ceiling trusses. And I really like how that turned out. It looks really nice. A couple things that are interesting about this unit. If you look, there's an access panel on this right and this left side. And those access panels are pretty unique to Carrier. For electric and drain, I don't need attic access anymore. I can get access from those two panels. This unit's also unique in that it has an RH sensor. It's got a humidity sensor on there, which is going to give us an enhanced dehumidification. Now this one's really easy to clean and service, but if it was a Carrier head mounted unit, one thing that's unique about the wall heads from Carrier is a trained service technician in less than a minute can actually pull that entire assembly out and do a deep clean on it. It's super easy. So that's something that's a little unique about Carrier. That being said, guys, let's go check and see if we can find Rheia over at our HVAC closet. I know Nathan is just finishing up putting our back dam, our marble threshold in there. He's using a little bit of Lexel and getting that set up, but I believe Rheia is over at the water heater, and let's go talk about LG water heaters. Voya, you in here, brother?
Yes, sir.
Hey, there you go. Good to see you, brother.
Hey, Matt, good seeing you, man.
Guys, Voya is an old friend. He's been around a long time in the building science world. I gotta tell you look sharp today, dude. The red jacket.
I appreciate that. Thank you.
And look at this, he's got his LG logo on too.
I'm hiding it today a little bit, but I figured the red stands up a little bit better.
So Voya and I have been friends a long time. He's every bit as nerdy as I am. So we're gonna get some good info from you, Voya. First, let's talk your LG heat pump water heater. What do you think about this install?
I actually like this install a lot. The piping's clean, everything's done beautifully.
This thing, when it runs, is gonna grab the heat out of the house, dump that heat into the tank, and we're gonna talk about your technology in a second on that. But what you need to know is that this unit, when it's running, is gonna make cold, dehumidified air because it's pulling the heat from the space. Now, Voya, I specifically designed this house with Steve Basic and put this in a more centralized location rather than the garage, which frankly is a good spot to put a heat pump water heater too, especially in Texas where it gets hot. But I was looking for really quick water piping. My buddy Gary Klein has taught me, the more central we can get that water heater, closer to the fixtures, quick water delivery. So that's the reason the central. Now, because this unit is gonna put off some cold air, I wanted to put some hot things in the closet with us. If you look on that top shelf, Voya, we've just started installing some Sonos equipment.
Okay, I
So
see
I've got
a
a whole
lot of
house.
wiring there, yeah.
I got a whole house Sonos system, and their amps, I have them in my house. I love them, but you have to know they make a little bit of heat, which is a good thing to co-locate with my heat pump water heater.
Absolutely.
So, now you asked about the vents. The vent on the left is my Santa Fe dehumidifier output.
Okay.
So that's a smallish unit. I think it's an 80 pint unit, probably 100-ish CFM. I'd have to look up the exact spec. So when it's running, it's gonna dump hot dehumidifier in this closet. Again, adding some extra heat to the space. The other vent that you see in there is tied to this bath fan, which by the way is on. That's a Fantech 80 CFM bath exhaust fan. And it's not exhausting the outside, it's simply looping the air from this big air volume into this small air volume. Because I think a lot of people make the mistake of putting this water heater into a closet that doesn't have a good air exchange in and out. I want to say your specs might be 100 cubic feet of volume, a 10 by 10 by 10 closet is the minimum size. Does that sound about right?
700 cubic feet unless we have a path for air to move, right? Whether
Okay.
we have a louvered door,
Yep.
whether we're providing active or passive supply and return. The goal there is to really make sure that we don't overcool this space. We don't want to go below dew point
Right.
and cause all kinds of moisture issues.
Exactly.
And we also don't want to make this thing have to work harder than it has to, right?
Yep.
If we're going to locate it inside the actual building envelope, then we want to feed it that nice 70-ish degree air continuously because that allows it to operate efficiently.
Yep.
As this thing operates, it's going to put off about 150 CFM of cold, dehumidified air off the heat pump itself, right? Because
Right.
that's how a heat pump works. It's going to extract air from the air that's warm inside the closet space,
Yep.
dump that heat into the water, but then we got to do something with that cold air.
Yeah.
So having a little bit of pressurization inside this closet, so as it operates, and I'm assuming we're going to provide some kind of a passive. I see a note you put on here to undercut the door.
I realized that before you came today. Oh shoot, I didn't get my undercut done. So we could actually use ChatGPT to do the math for us to figure out
Absolutely.
the undercut. But we need enough space that air can pathway out. Now this is a little funky, but the closet actually has two doors that can be undercut. So this door here, and actually my hallway coat closet door also will get undercut. So now I've got two return pathways out of that.
So you're going to have about 3 inches by 24 inches across the board, right?
Yep.
Of undercut surface area.
That's exactly right.
That should give us about 150-ish, maybe a little bit more.
Yeah, that's the idea.
CFM of airflow under a 300 CF or 300 feet per minute velocity, which is
Yep.
going to still be nice and quiet. It's not going to create any kind of a static pressure.
Yep.
That should allow this thing to breathe efficiently.
That's right.
And to make sure that we're keeping the conditions inside this ideal
Yep.
for the operation of the heat pump water heater, and to make sure we're not causing any kind of structural issues.
This one has a turbo mode.
Yes.
That I wasn't quite sure in reading the literature. What is that doing for us?
All right, so let's talk about all 4 modes on this one, and then we'll touch on the turbo mode. So
Perfect.
we're going to start off with the mode that I have the system in right now, which is auto mode.
Okay.
This water heater employs a heat pump. And in addition to that, it has two heating elements, two 5 kW heating elements, one on the top, one on the bottom.
Okay.
Important thing to note is they never run both at the same time.
Oh, that's interesting.
They're strategically positioned so that one activates when the water heater senses that it needs a lot of pass-through.
Okay.
Okay. The lower one will activate when it senses that it needs to recover the entire water volume of the tank quickly.
Fascinating.
Right? So you get a faster recovery of the whole tank from the bottom, but you get a faster hot water delivery if you're heating from the top.
Okay.
Right?
Makes sense, yeah.
So it knows which heating element to activate.
Yep.
Another important thing, standard heating elements. So for service, if one ever fails, they're serviceable through this panel right here. This pops
great.
off.
Cool.
2 screws, remove the heating element, go to Home Depot, buy a new one, plug it right back in.
Fabulous.
Right. So we provide warranty, but if it's a pinch kind of situation, get it done, get back to us, and we'll go ahead and work out what we need to do to provide a replacement for
That's killer. So that's auto mode.
That's auto mode. The other thing to notice in auto mode is when we are in auto mode, we are going to look for a 20 Celsius, so that's about 36 degree Fahrenheit, delta T. So that's the differential between our set point and the temperature of the water actually in the tank at the time.
Okay.
Before we activate the heating elements supplementally to the heat pump.
Got it. In other words,
So-
let the heat pump do its work because it's very efficient.
Much more efficient.
However, if I have 10 relatives over and we all shower back to back, we drain this thing.
Yes.
It knows, oh shoot, we got a big delta T here. Let's go ahead and activate both the heat pump and the elements.
Correct. But in auto mode, the important thing to notice is going to wait for that 36 Fahrenheit degree difference between set point and where your water is.
Got it.
Right?
Okay.
The other important thing to note also on these is that unlike the old and traditional hybrid and heat pump water heaters, where they can run just a heat pump or just a heating element, it's never both. Mm-hmm. With this technology, we run the heating element in addition to the heat pump. So
that's
we do
cool.
not lock out the heat pump until we get below 20 degrees Fahrenheit.
Oh, that's
right?
great.
So the low end for this heat pump water heater is 20 degree ambient.
Okay, inside temperature.
That's
Of the
if
air
you put it
around
in
it.
a garage, for example.
Right, and you were in
and
Connecticut.
And you go below 20, it's going to deactivate the heat pump and it's going to run as a electric
Oh,
water
that's
heater.
smart.
Right?
That's some good engineering right
So
there.
it's a heck of a lot better than like 40-ish degrees or so, which what
Right.
we've seen in 10, 15, 20 years ago, heat pump water heaters.
That's right.
Huge advancement.
Yeah.
The next mode is going to be turbo mode.
Okay,
That's
so
the one
what's-
you want to know about.
So what's turbo do?
The only difference between turbo and auto is that it narrows that delta T differential between set point and water temperature. So now instead of looking for 36 degrees or 20 Celsius, it's looking for 12 Celsius, which is about 22 degrees.
So in Matt language, this is the hair trigger mode. Like, hey, I
Correct.
think we're probably going to need some
Yes.
extra hot water.
This is what you're going to want when you
My-
have all your in-laws
My
coming over.
company's coming over. I'm going to hit this baby in turbo mode,
Yes.
so it doesn't wait for the tank to be colder. It's going to go pretty quick.
Correct.
That's
Which
smart.
again
That's really smart.
allows the heat pump to do its work
Right.
much, much faster.
Yeah,
And we have less need for that supplemental heat
super smart.
once we kick it in, right?
Okay,
the
so
next-
that's auto and turbo. What's
Yep.
next?
The next mode is going to be vacation. This is going to set the temperature back, the actual set point temperature back,
Yeah.
by roughly 30 degrees.
Don't run. I'm not here.
I'm not here. I don't need to maintain it.
Yeah.
I just want that water temperature to stay warm enough so I don't have freezing pipes or any kinds of issues like that in
Super
Connecticut,
smart.
for example.
Right.
Right?
Yeah.
The next mode after that is going to be heat pump. That is going to lock out the heating elements, and it is going to operate at its peak efficiency, only running heat pump.
Okay, so let me pause on that for 1 second. I coach over the year. I've been putting heat pump water heaters in since the very first one came in the market, probably 2009. And I coach my clients run it on eco mode, or in this case, heat pump only mode to start, because I've found 99% of the time no one needs anything but heat pump mode. It makes a ton of hot water, and we also went with the 80-gallon size here. So when I'm running at 120 degrees, I've got 80 gallons of hot water standing by. This family of 4 that's going to live here, I doubt they're ever going to need to do anything but heat pump mode. Would you agree with that?
I would pretty much agree with that. I do want to mention, because the air intake for this water heater, the supply air is on the top, we also have a cleanable, washable filter up.
Gotcha.
Very, very important for homeowners,
How
plumbers
often
doing
should
service.
we be checking that? Every couple months?
Check it once a month, I would say,
Yeah.
and just clean
See
it
what it
as
looks
need
like.
to, right? Yeah. Kind of like you said, start more often in the beginning,
Right.
and you learn eventually how often you need to check it. But it's
Yeah.
very, very simple and easy to pull out completely. I'm not going to do it right now because then I'll have to try to figure out how to like find exactly the slots to put it back in.
I like it.
But you know, with a little step stool, you can see easily, pop it back in. That's it. Cold air is going to exhaust against the back. We're pretty much covered across the board.
I love it. Let's switch gears and talk about some other LG appliances going in this house.
Absolutely.
Which, as a matter of fact, are going to go right in front of us, Voya. We're in the laundry space. This is kind of a big room.
Okay.
We've got my emergency overflow pan. Not that I don't trust your LG appliances, but I like to have an emergency pan everywhere that does have a drain to the outside. And Voya, when I started the project, I wasn't sure which equipment I was going to use. So I've got an exhaust for a dryer here, but we actually don't need that, do we?
I was going to say, when I first walked in here and looked at that, I went, wow, so why did
go
you
check it
spend
out.
all that time cutting a hole in your building?
Well, you know, I do actually like the idea of having the ability to change out. Now, there's no gas line in the house, but I thought if someone doesn't use this laundry someday, 20 years from now, they've got the option, right? So we put a vent
Absolutely.
in, but this baby is
Ventless.
ventless.
This baby is, yet again, we're going to keep talking about this, dual inverter heat pump. So variable speed inverter, heat pump is built in. This thing, as you
come
mentioned
around
it,
the
that we
back,
look at
yeah.
the back, there is no vent anywhere here.
Yeah, so
right?
when you look at the back of this unit, I'm gonna slide it over for the camera a little bit. You know, a typical dryer has got a big tube right here, a 4-inch duct that's gonna push to the outside. You can see we put that recessed dryer box in so that wouldn't kink. Now, in the future, maybe they need that, but this unit doesn't exhaust anything out of the house. Back of the washing machine, normal, right? But this dryer is recycling the air. Now, we do have a condensate drain. You're gonna show us
There is a
that right
condensate
there.
drain that comes with the dryer, and I'm going to show that right now.
Because it
And
will make condensate.
Correct. Because as we dry the clothes, all that moisture has to go somewhere.
Yeah.
In a typical situation, so let's talk a typical electric or gas dryer. What's going to happen is you're going to have about 200 CFM of air being exhausted outside,
Dumping outside.
right? And you have a tight house.
Yeah.
How many of us think to provide makeup air
For your dryer.
in a tight house for a dryer, right?
I
We
know.
think about it for a kitchen exhaust
Yeah,
hood,
for sure.
but we don't think about the dryer.
Yep.
This is a 200 CFM exhaust that's now taking our conditioned air,
Yep.
drying the clothes and dumping that conditioned air with the moisture outside.
That's right.
This thing actually instead recycles that, condenses that moisture, and we dump it through the condensate tube.
Yeah.
But what I really love about it is because this is such a thin condensate tube, we can now just use the same exact condensate drain
All right, we're just using the same
for
drain
our
as the washer.
Yeah, we're just gonna pop both of them into the same hole, call it a day.
Yep.
That's all the installation you have to do other than plug it in,
Yeah.
right? On a typical dryer, if you were to do a single load, this lint filter would probably be filled up.
Yeah.
So you got to service it after every single use. This thing will probably take close to a month worth of loads before it actually fills up the lint filter.
Wow, how about that?
Now,
Not supposed to do that.
that's not to
This isn't
say
advice.
I don't want you to check it and clean it after every use. 'Cause
Every load
remember,
needs to be checked.
airflow is important for drying of the clothes. So
Yeah.
the less airflow, the longer the drying cycle takes.
That's right. Yeah.
So clean it after every use. But what you're going to notice if you switch from a standard dryer to a heat pump dryer, you're going to notice a huge difference
Mm-hmm.
in how much lint is actually there.
That's awesome.
That means that you're not ruining your clothes as
Yeah,
often.
yeah.
So this red
more
jacket,
gentle.
if I want to throw it in on steam cycle, get a little bit freshened up. We are in Texas.
Yeah.
It's a little hot and
Yeah,
smelly out here.
For sure.
But if I want to freshen this thing up, I'm going to keep this thing for about 4 times as long as I would if I just threw it in my standard
That's a big deal.
dryer, right? And we're talking about our washer. Typical standard washer, couple of differences from, let's say, my mom and dad's washer, right?
Check this out. It's
These
got
babies.
a detergent and a softener. So what you do is you put your Tide Ultra Oxy liquid, fill this sucker up, and now it's going to auto dispense, right?
Correct. It's going to weigh the load. It's going to use its internal sensors to determine the fabric type, and it's going to automatically determine how much precisely, based on that fabric type and based on the weight of the load, precisely how much detergent it needs to dispense. Most of the time what we're gonna do is we're gonna fill up a cap,
Right.
we're gonna dump it in here, right?
Yeah.
Whether we were washing 3 t-shirts or an oversized load.
Sure.
This is gonna apply exactly what it needs when it needs it. Now,
Smart.
if you wanna go ahead and just do your own thing,
Sure, you can still do that.
you can still do that.
Sure.
You can still fill your liquid bleach in here. That's the only thing that's not going to be measured is liquid bleach, right? Because
Don't use liquid
this thing
bleach.
doesn't know if you got whites only or if you got just lights.
I'm an Oxy guy. I really like the Oxy products.
absolutely.
I don't use any liquid bleach.
So ThinQ is our app, our interface.
yeah,
A lot of folks that have LG products in their homes, TVs, other laundry appliances,
that
kitchen
app.
appliances. A lot of our product is Wi-Fi enabled.
Killer.
Right? So what I can do with this setup or with your soon-to-be new LG all-in-one washer dryer, you set it up and you hook it up to your ThinQ app. You hook up your water heater to your ThinQ app. Your HVAC products that are LG, you hook them up to the ThinQ app. Your appliances in the kitchen.
Cool.
As it actually completes the load, or if there's any issues, it's going to message you. So lots of really cool benefits because LG, just like other companies out there, our goal is to make the consumers' lives as smart and as good as we possibly can. And all of these appliances, ThinQ, that's really just another step towards making a smart home that's out of the box, ready to go, without having to invest into like all kinds of third-party stuff that we had to do 10 years ago.
And how cool that LG realizes a smart building science guy like Voya is really good to have on staff so that when I'm building a tight, energy efficient home, I can put a heat pump dryer in, and we've got guys like Voya that I can call and ask a question. Same with that heat pump water heater. Voya, thanks so much for making the trip to come see me today, brother.
Matt, always a pleasure to come hang out, see what you guys are doing. Man, I'm loving it, and I can't wait for the next project.
We got to get back to the HVAC commissioning, so let's go find Ron and talk about the Rheia duct system. Okay, y'all, just to remind you what the Rheia duct system is, this is that gray flexible piping that we use for the HVAC system on the first floor. It's a home run system, meaning it runs direct from the furnace all the way to the outlet. It's not a trunk and branch system, and it was really easy for us to route through the first floor trusses. So that being said, let's go find Ron and we'll show you how we actually commission this ducting system on the first floor.
Thanks, Matt. Here we are today at the Rheia build. We're going to be working on the commissioning process on the Rheia air distribution solution. Every Rheia installation should go through the commissioning process utilizing our 2 web-based apps, Rheia Manage and Rheia Verify. Rheia Manage is what's used to manage the contractors, the builders, the communities, and the design files. And Rheia Verify is what's utilized by the technicians out in the field to verify that the system's operating within the design parameters. Today, we're going to be going through that process. It starts with making sure that you have all the right materials in place to do the commissioning process. The tools necessary are a flow hood or a bolometer, an iPad to run the app, and then manometers to take static pressures of the system. First step is walking through the home with the design in hand, ensuring that all the distribution points are installed in the proper locations by design. You make sure that all the diffusers are either on or off, and make sure that all the dampers are positioned in the open position. That's how you start out the project, and that's what we're going to start with here today. When preparing a house to go into the commissioning process, you want to make sure the orientation is selected correctly. Depending on which way that house faces to the sun, it could change that airflow demand by a room. So in the app, you want to make sure that you're selecting the proper orientation. By doing that, the design's referencing the front door. So if you pop open most phones, they do have a compass on them. And if you take that compass and just set them against the front door, that front door for this particular house is facing northeast. So you want to go into the app, select the proper orientation, and now it's going to give you the correct airflows by the orientation of the house for that specific design. As mentioned, we're going to start the process by making sure that all the diffusers are installed or absent, and making sure that all the dampers are in an open position. To do that, you want to walk through with the design in hand, making sure that all the diffuser or distribution points are in the proper location by design. All the distribution points are cut out behind the drywall, make sure that they're exposed, and making sure that, again, all the dampers are in an open position. So by design, we're looking at the living room register here. All we're going to do is make sure that the diffusers are on or off, and then making sure that the dampers are in an open position. To take off the ceiling diffusers, all it is a quick slight turn to the left to take them off. And you can see the damper in this distribution boot. You want to make sure that it's in the open position. They have 5 fixed positions. Right now, this one is wide open. If you saw that it was at an angle or closed, again, you want to make sure that they are all wide open. So this one's in good shape. We're going to go ahead and do that throughout the entire home. Now that we've verified that all the diffusers are off and all the dampers are in the open position, the technician's going to log into the Rheia Verify app. From there, they're going to select the proper community, the proper lot, and it's going to take you straight into that lot where the JSON file, which is your actual design file, is operating in the background. The first step that you're going to do is look at the global settings. It's going to call out the air handler information, which is really just the model number. You're going to make sure that the correct piece of equipment has been installed to the manual S. It already calls it out on the app itself, so you're just verifying that the right piece of equipment's been installed. Once you've done that, you could go ahead and add the serial number for that piece of equipment for your own references, and then you're going to advance by hitting Verify and Proceed on the app. The next step is it's showing you the blower settings. As you can see, it shows the heating demand, the cooling demand of airflow. You're always going to pick the higher of the 2 airflows to ensure that you have the right amount of airflow to condition that home. It also shows you what the design static pressures are for that system. You're going to utilize the blower data chart from your specific piece of equipment, taking your static pressures, making sure that you're delivering the right amount of airflow. To do that, you're going to need your manometers on both the supply and return side of the system, taking proper static pressure readings and inputting that information into the proper fields on the app. Let's go do that now. So now we're going to start with the global measurements. The first thing you want to do is remove the filter. We have the filter removed because that could be a variable. Every HVAC design starts with a static pressure of the filter. So you want to make sure that it's removed because it may be the wrong type, could be dirty, and that's going to throw off what our static pressure readings are. We're going to add that static pressure on the back end, so we're not removing it and ignoring it. We just want to eliminate that variable and keep a steady baseline. So we've already gone ahead and removed the filter. We went ahead and installed our supply and return static probes to make sure that we're getting an accurate static pressure reading. We're going to go into the app and we're testing at the rough, so you're going to make that selection. We're going to be testing the equipment in cooling mode. We have the diffusers absent. And we're going to balance to cooling because we're in Austin, Texas. So it's a cooling dominated climate. We're not going to balance to the average, although you can depending on what climate zone you're working in. If you're in a multi-climate zone where you have multiple seasons, you're going to want to balance to the average, and you're going to want to recommission that home or rebalancing it depending on the seasons. That way you're living in your home as comfortably as you can, as optimally as you can. From there, we're going to enter the static pressure measurements that we're finding on the system. And we're doing that again based off of the prior screen that showed you what the target CFM is for heating and cooling, as well as the design static pressures. Now we're getting into the balance portion of the commissioning process. On the app, it lists out each room name just like it shows on the manual D. Whenever you click on the room, it now is going to tell you what distribution points are in that room with the specific name to each distribution point. So we're in the living room. And you can see it has all the different fields for all the different distribution types in that specific room. We're going to start here on the right-hand side where the register name is just living room. We're going to go ahead and tap on the field. We're going to grab our barometer, take the airflow measurement. Once you capture the airflow measurement, you're going to go ahead and enter that into the field. And you're going to go throughout the rest of the home and take those same measurements and enter them in just like it calls out on the app itself. So you're just following the prompts on the app and entering the information as necessary. You don't want to be overly concerned about the measurements. You don't want to get too focused on it. All we're doing is setting a baseline of what we're trying to achieve. So as you go through, you do want to pay attention in case you get a 0 or a number that may be off compared to some of the other distribution points. Whenever you think about a Rheia distribution system, because it is a home run, each one of those ducts are coming from the same area. They're all going to one centralized manifold. So if you have multiple distribution points in the same room, and they're pretty comparable as far as distance goes, those measured airflows should be pretty comparable. If you're measuring 30 CFM, 30 CFM, and then all of a sudden you're getting 10 CFM out of another distribution point, you have to think about why that's happening. Maybe there was a hard bend and maybe a fitting wasn't utilized, or maybe something was run a little bit too loose and there's a lot of resistance within that duct. Paying attention to the measurements while you're going through the process helps you determine if there's an issue. If you ever measure a diffuser and there's a 0, that tells me that someone either disconnected a duct or there wasn't a good connection in the first place, and you want to make sure that that's being executed before you move forward throughout the rest of the home. Otherwise, everything you've done to that point is going to be inaccurate. So although you're not going to be dialed into exactly what's going on through this portion of the process, you do want to pay attention to the measurements that you're getting. So once you've gone through the home, taking the measurements and entering them into the app, all of the rooms are going to turn from red to green, letting you know that you've measured all of those individual distribution points and all the information is proper. From there, you're going to go ahead and hit balance on the app. And what it's doing is it's taking all those airflow measurements that you've taken in proportion to the static pressure of the system itself. And now it's telling you what dampers need to be adjusted to try and deliver a balanced home. Once you've hit balance, you go ahead and you click on balance results. And now you'll see there's certain rooms that have turned red. Those rooms are the ones that need to be adjusted. So now you're going to go back through the home, adjust those dampers accordingly, and replace the diffusers as you make those adjustments. We're going to go ahead and do that now. So each distribution point on the Rheia system has 5 fixed positions. Position 1 being all the way open, position 5 being all the way closed. Whenever you go through the balance process, the app will tell you what distribution points need to be adjusted to what damper position. So this specific distribution point is started off in wide open like we talked about. It's telling us we need to close it down to position 3. So with those fixed positions, you just count. With position 1 being open, that's position 2, that's position 3. From there, you're going to go ahead and put the diffuser back on. You line up the 2 tabs to the 2 openings on the distribution point, press it in slightly, and turn to the right. You'll hear the diffuser click into position, and that's how you know you're on. Once we've gone throughout the house making the proper adjustments and putting the diffusers back on, we want to take our final static pressures one more time. As we restrict dampers, that's going to increase our static pressure. So we want to take that final static pressure to make sure that we're still operating within the design static pressure of the system. Let's go ahead to the air handler. We'll take those static pressure readings. We'll put them in the app, and now the app's going to produce a report for us. And I'll talk through that reporting, how to read it, and how to determine that the home is operating within the design parameters. So whenever you're taking your static pressures, you always want to make sure that your tools are zeroed out and calibrated at 0 to start. You can see that these 2 are open to atmosphere right now, but they're not calibrated. So we want to go ahead and zero those out before we take our static pressure readings. Now they're at 0, we're going to go ahead and put them into the system, take our final static pressure readings, and enter them into Rheia Verify. Whenever you're taking static pressure readings, you should be using a pitot tube. That's the metal tube, and you want that point to point into the airstream. It has a sealed end, and that's how you could remember having the pitot tube always pointing into the airstream. So on the supply side, this being an upflow piece of equipment, we're going to have that arrow in the point of that pitot tube pointing down into the airstream. On the return side, we want to have the same thing, the pitot tube pointing down into the airstream. And because this is a free draw mechanical room, we want to make sure that we're taking those measurements with the door shut. Once the system's balanced out a little bit, you can see on the supply side, we're at a 0.41 static, and on the return side, we're at a negative 0.02. Your return should always be a negative static pressure number. We're going to go ahead and enter those into the app and review the Verify report through Rheia Manage. Now that we've completed the Verify process, we're going to log back into Rheia Manage and review the Manage report. We've logged into Rheia Manage at manage.rheicomfort.com. We're going to select on Reisinger Build. We're going to go to Divisions. Then we're going to select Division Details. We're in Austin, so we're going to go ahead and click on Austin being the division. And you can see that we're at the address of the home. Air Right Design did the installation, so we're acting as if we're the HVAC contractor right now. And we're going to go ahead and click on the lot. You can see that the commissioning was completed on 5/27 by TEL with Air Right by Design. The first button here that you click on, it's actually giving you your short summary report of your manual J design. You can see that it lists all the names of the room of the house, the cooling CFM demand, the heating CFM demand, and the average of the 2. The third button here, whenever you click on Results JSON, that's the coding of that JSON file, the HVAC design file. Whenever you go through, it shows each room in the airflow that was measured in the field that was entered into the app itself. The middle button is really the important one that we want to look at. That's where you'll find the Rheia Verify report. This is a short summary of it, listing the name of each room, the airflow, the target airflow, the CFM difference, and the percent difference. And then the last one is the damper positions. Anytime you see multiple numbers on the damper positions, that's because there's multiple distribution points in that room. At the top of the page, you can see that you could either download a PDF or you could open it up in the web browser. All the actual design information that was put into the Manual J, Manual S, Manual D calculations of the home. We're going to skip down to the bottom portion and talk through some of the terminology that's used within the Verify reporting. Here you'll see a little bit of a terminology glossary, if you will. Whenever we talk about airflow, we're talking about the normalized predictions of airflow based off of the static pressure and the airflow measurements that we've taken in the field. The target airflow is the target airflow that we want to achieve based off of the Manual J design information. The delta is the difference between the target airflows and the measured airflows in the field. It has a percent difference and it has a CFM difference. We want to fall within the ACA standards, which is 25 CFM or 20% of that Manual J design target. The last portion is the damper positions, position 1 being all the way open, position 5 being all the way closed. You want to utilize that information to determine if this house is balanced correctly. So we're going to go back up to the Verify portion, and we're going to start with the information that we measured out in the field. You can see that our final static pressures have been entered with the proper orientation of the home. Checking the orientation of the home is very important. Whenever a JSON file is uploaded within to Rheia Manage and Rheia Verify, those airflows are going to change depending on which way that home is oriented. So whenever we started the process, we made sure that the orientation of the home is selected correctly. And what you do is you take a compass, stand at the front door, which way you're facing, take that orientation and enter it into the app itself. So we were facing northeast, so it calculated the proper airflows based off of the orientation of this home. From there, we want to look at these two columns, the delta and the percent delta. Just like we had mentioned in the glossary, we want to be within 25 CFM or 20%. Now, smaller rooms, you're going to see a higher percent difference, and that's okay because we're still going to be within that 25 CFM range. Remember, this is just balancing the equipment based off of the information that we're putting in. So you have to make sure that the system is set up correctly with the proper blower speeds to the design, you're taking proper airflow measurements, and you're entering it in accurately. From there, you can see that we're well within the percentage range. Even though on some of them we're very high, we're still within the 25 CFM range. When you look at the one room here, you can see that the guest bathroom is still a little bit high and it's only targeting 1 CFM. The reason the app didn't balance that out further is because we want to still be within that proper design static pressure. So whenever we look at our design static pressure measurements that we measured in the field, we're at 0.41 on the supply and negative 0.02. That gives us a 0.43 of static pressure. But like we talked about earlier, we have to add back in the filter static pressure, which for this system is at 0.15. So now you're adding that 0.15 measurement on top of the 0.41 and the 0.02. That gives you a total static pressure of 0.58, which is very close to our target design static pressure of 0.60. We don't want to go over our design static pressure because that could cause your system to either trip on a high limit or freeze coils in cooling season. So the app is actually going to protect the system by not going too far above that design static pressure. Again, this is just a target guideline. You could always make some fine-tune adjustments either to a homeowner's personal preference or to try and get this balanced in a little bit tighter, but this is going to get you where you need to be very accurately, very quickly, as opposed to a conventional air balance where every time you make an adjustment, it affects everything else you've just done. This is a one-stop, one-shot through, and you're going to get these predictions very accurately to the system. So that completes the commissioning process of the home. Just want to say thank you to Matt Reisinger and the Build Show team for the opportunity to work with everyone on this project. It's been a great experience for all of us. I hope it's been a great experience for you. If you have any questions regarding the Rheia air distribution solutions, you can find more information about Rheia at rheicomfort.com. Feel free to reach out to any of us. We'll be more than happy to point you in the right direction on how to utilize Rheia as an air distribution solution for you. Thanks again, Matt. Back to you.
All right, y'all, listen to this. I'm right up on the unit. It ramped up its speed a little bit on the fan, but man, that is incredibly quiet. I'm gonna be silent for 1 second here. All right, now I stand up and I'm not in the wind speed anymore. I don't know what that is, but that feels to me like it's maybe 40, 45 decibels. I wish I had my dB meter. It's really, really quiet. Look how clean this install looks too. Electrician's got our AC disconnect on the side. I do wish that I would have had my mounting block a little bit taller. It's not that big a deal on the end. And then check out that Titan outlet. Whew, those look real nice, don't they? They've got their PVC covers going from AirX Manufacturing, and those line sets and the insulation are totally protected. This is my secondary drain from the inside that you're seeing here. Again, AC disconnect. I wish that block was a little bit longer. Oh well, next time I'll do it a little bit better. This block couldn't have been any more perfect though. Again, that's that Titan outlet. So this pipe you're seeing here, this is actually the drain that's in the floor, and I believe this is also connected to another floor drain, potentially the pan for the laundry unit or the pan underneath the dishwasher. So those are draining there. Those are emergency only drains. There's a P-trap in there. We filled those P-traps with mineral oil. One thing I need though that I'm not seeing that I think I need to get before the final episode, this doesn't have a screen on it. I want to add a, basically not like a bug screen, but more like a rat screen to make sure that critters couldn't get in there. They sell those in various places, so I'll see if I can find that screen before we finish this, this house out. But guys, the house is looking amazing. I mean, look at it. I'm so proud of how this thing's turning out. The James Hardie siding, the paint job, all the trades have just done a fabulous job here, but super fun to see this commissioning happening from both my Airite guys and the Rheia duct guys. I thought Ron did an amazing job explaining. And I love the idea that if we do get some need to come back and work on some comfort in the house, that Rheia system really makes it easy for us to do it. But in the end, I think this Carrier system, along with a really good envelope, a fresh air system, this is really gonna deliver some amazing results for these clients to live in. Stay tuned for my final episode though. We'll crawl in the attics. I'll show you the maintenance schedule that we've set up for our homeowners. We'll show you how the fresh air system got commissioned. We'll look at the final finishes on the house. We're getting really, really close. If you guys don't know, by the way, this plan, as well as my house, is available on the BFS Home Plan Library site. So if you wanted to build this exact house that we've done now 23 episodes of construction on, including the specs, you could build this exact same house. They've got that all available for you. You could use the ready frame package like we did to build this thing super fast. But we're about a year of construction right now. I realize that's long for some people and it's quite a bit shorter for a lot of my projects. This has been a really fun project. BFS, an amazing partner. Go catch up on the previous episodes if you haven't, and stay tuned for our final walkthrough that is coming next. With that being said, guys, this is the Rheia build in partnership with our friends at Builders First Source. We'll see you next time on the Build Show.